Hi everyone, can you all see the whiteboard?
Yes, we can see the whiteboard.
Okay, good. Okay, good. Yeah, 995 is correct. Bharat, can you explain?
Yeah. So I let X be the number of people and Y be the amount of people in the fund. So the first equation is 50x is equal to x plus 5, or y plus 5, and 45x is equal to y minus 95. And if you subtract those two equations, you get um, uh, uh, 5x is equal to 100, so x is equal to 20, and then if you just substitute x for 20 in one of those equations, you get y is equal to 995.
Good. Yep, that's correct. So yeah, this is one way of doing it. We can do it algebraically by setting a variable for the number of people. And then we know that 50x is equal to the company fund plus $5 extra, since it was $5 short. Versus if it was 45x, $45 per person is the company fund minus 45. And you have two equations, two variables. You can solve for x and use this, plug it back in, and solve for y again. And you'll see that y is equal to 995, plugging. Plugging it back in. Okay, is there any other way of solving this?
I did it a different way.
Okay.
So, so I first needed to find the number of employees.
Mhm.
So, I subtracted 50 by 45 to get 5. And then I took that and saw like the number of like the dollars for like each bonus. And then once I added them, I got 100. Once I added 5 and 95, I got 100. And then after that, I divided 5 and 100 and got 20 employees. And then I multiplied that by 45 and added that by 95 to get 995.
Good. Yeah, so this is another way of doing it. And the idea here is to think about, so if you gave $50 to each employee, you'd be $5 short. But if you gave $45 per employee, you'd have $95 left, right? So basically, what's the difference between giving $50 per employee and $45 per employee? It's giving $5 to each employee. And we know the total and the difference is 95 plus 5. So $100 must have been equal to giving $5 to each employee. Does that make sense? So if you know that $5 to each employee is a total of $100, you know there's 20 employees. I'm sorry, I think I first had 10 here, but this was 95, so it becomes x equals 20. So you know there's 20 employees. Now you can go back and say, okay, $45 per employee left $95 in the fund. So 45 times 20 plus 95 leaves us with 995. This way it doesn't need any algebra. We can just think about $50 bonus to each employee versus $45 bonus to each employee. The difference is $5 per employee. And you know that accounts for a total of 95 plus 5, or $100 difference in total. So that tells you the number of employees, and plugging that back in gives us the total number. Any questions on this? Okay, let's move to the second one. Okay, any answers for this one? Okay, I don't think I see the right answer. Actually, I think the question was even supposed to be just divided by 5. Not sure why it became 500, but so let's start off with just that, and then we can think about if we can get 500. Any ideas if I made this question 5?
Would it be 14152?
So for divide by 500 or divided by 5?
Divided by 5?
Okay, so the remainder should be, so what is the remainder when the product is divided by 5? The remainder has to be a number smaller than 5, right?
Would it be 4?
Good, why 4?
Because you can just multiply the last digit of all the numbers. So you get 2 times 6 times 2 times 6, which is just 12 times 12, which is 144. Then if you divide that by 5, you get a remainder of 4.
Good, yeah, that does work. So why do you only take the last digit?
Because if it's 5, you don't really need anything else besides the last digit. It's not really
Good. Yep. But let's to just make this clear. What if I had 7 here? Would the same trick have worked?
No.
Okay. So what would I have done instead if it was 7? And we'll go back and apply the same thing if it was 5 as well. But for now, if it was 7, how would I do it then?
Would you have to do the last 2?
Would you have to do what? All right.
Or the last 2 digits?
Actually, that wouldn't work either. But any guesses why? Okay, so let's think about why. So for 5, why does the last digit work? But let's think about it in terms of if I write this number as so let's make it an even smaller product. Let's just say 1492 times 1776. Okay, now I want to find what is the remainder when this is divided by 7. What if I could write each number as 7 times something plus something, which is basically its remainder when divided by 7, right? So this is actually 7 times 213 plus 1, and 7 times something else plus 1, plus something else. So does it make sense? All I did here is I'm just saying, let me write 1492 as 7 times something plus something else. And let me write 1776 as 7 times something plus something else. Does this help me figure out what this product's remainder is when divided by 7?
Would it be the plus 1 plus b, 1 plus b, or 1 times b?
Good. Why 1 times b?
Because 7 times 213 doesn't have a remainder because it's already a
Okay, yeah, that's true. 7 times 213 doesn't have a remainder. But when I multiply this out, there's a lot of terms, right? So is there any other term that I need to worry about here? So what is this product?
It would be 7 times 1492A plus 1492B plus 7A plus B.
Okay, instead of 1492, I'm going to leave it as 7 times 213 just to make it clearer to see. But okay, yeah. 7 times 213 times A. So all I did was multiply this term, the first term, and the first term of each, plus 7 times 213 times B, plus 7 times A, plus B. Okay, so now this term has a multiple of 7 in it. This term has a multiple of 7 in it. This term has a multiple of 7 in it. So the only term that doesn't is B. And what is B? So 7A plus B is just whatever I can rewrite 1776 as. So what can I write 1776 as to be in this form? 7 times A plus B.
$253. Would A be 253? And then plus
plus
4. 4. Oh, no, plus 5.
Close, yeah. So what's the answer here?
5.
Good. Okay, so what is the trick here? If I ask you the product of any numbers and what's its remainder when divided by something like 7, what do I have to do?
You have to find the greatest, how much the most you could divide one term by, and then add the remainder, and then you can just, and then do it for both the terms, and then multiply both of the remainders.
Good, but yeah, careful. No, multiply, not add. So this term, so in this case, I took the product of these two. So what I showed was basically, I can write each one as 7 times something, which is like my quotient when I divide this by 7, plus a remainder. And this term, I can write it as 7 times something plus some remainder. Now, when I multiply this out, all the terms have a multiple of 7 except the product of the two remainders. So basically, if I'm asking you what's the product of these two divided by 7, it's equal to saying the remainder of that is the same as taking the remainder of this term by 7 and the remainder of this term by 7. So if I wanted to do it for the 4 terms, I don't need to multiply it all out, divide by 7. I can take the remainder of this by 7, this by 7, this by 7, and this by 7, and solve for that. Does this make sense?
Yeah.
Does this also answer why the last 2 digits would not work?
Yeah.
Why?
Because 5, if you multiply it by 2, it always ends in a 0. But 7, it doesn't work like that.
Yeah, in a sense, yes, but I think the key thing here is that if I were to take 92 instead of 1492, it doesn't have the same remainder when divided by 7. And the reason is because 100 itself is not a multiple of 7. If 100 was a multiple of 7, I could just kind of forget about the first 2 digits and only think about the last 2 digits. But because that's not the case, I can't do that. I want to know the remainder when this is divided by 7. And that's not the same as just forgetting about the first 2 digits. But yeah, that's generally the correct idea. Okay, so let's go back to the original one, divided by 5. So one idea, yes, is the last digit. Now, if I apply the same idea as this problem, how would I do it here?
1490 divided by 5 plus 2.
So basically we're asking the remainder when dividing 1492 by 5.
So would it be 5 times 298 plus 2?
Yeah, so it is, but let's forget about the product term for right now. We just want the remainder term, right? We're gonna throw away these terms anyway. So what is the remainder?
Okay, so then 2.
Yeah, okay, what about the next term?
1.
Good. Next term?
2.
Next
1.
term. Good. So what is the?
So it should be 4.
4. Good. Does this make sense?
Yeah.
So you could get this here by just doing the last digit, and that does work because, so now why does the last digit work here is because the last digit has the same remainder when divided by 5 as the whole number itself, right? So that's why you could just take the last digit, and we know if I take the last digit and multiply it out, I know based on the last digit of the product, I can find what its remainder is when divided by 5. So that way also works, but in this case, this is a bit more general. Whatever number I give you here, you can think about the remainder of each term when divided by that, and then multiply that out. Does this make sense?
Yeah.
So if we wanted to increase this to 500, we could think about the remainder of this term by 500, this term by 500, multiply that, then think about the remainder of that, divide by 500, and move forward. Does that make sense?
So even if it was 5 or 500, the answer would still be 4, right?
Not necessarily, but it would tell us something about that remainder. So I don't believe the answer is actually 4, but what should the last digit of the remainder when divided by 500 be?
Wait, could you repeat that?
Okay, so I don't think the answer is 4 for when divided by 500, although it could be, but the answer, I know something about the last digit when it's divided by 500. What should the last digit of the remainder when divided by 500 be? So basically I'm saying 1492.
004.
Good, yeah, so it should end in 4. And the reason for that is because if I think about 1492 times 1776 times 1812 times 1996 is equal to 500 times something, that's my quotient, plus my remainder. So I know what the last digit of this side is, right? Now 500x, what's its last digit going to be? Or in fact, what's its last two digits?
492.
Huh?
492.
Yeah, so when you divide the first term by 500, they would be 492, yes. No, but here I'm saying for the whole product. So 1492 times 1776 times 1812 times 1996. Let's say I multiplied all that together, and I wrote it as 500 times something plus a remainder. So I know that the last digit of this whole product must be the last digit of the remainder, right? Because 500 times something will have 0, 0 at the end. So this remainder must have the last 2 digits of this whole product. So I know what should the last digit be.
Four.
4, good. So I know that this remainder should actually end in 4, but it likely has some other terms because I also have to have the same kind of second to last digit, and I'm covering basically, I want to know what the last 3 digits are of this product, and that helps me find the remainder when divided by 500. Okay, so I can multiply it out, but I'll leave this as an exercise so you can try it out. Try applying the same ideas and see if you can solve the remainder when divided by 500. Any questions on this? Okay, let's move to the last one. Okay, let's see. 30 is correct. Ishan, you want to explain how you got that?
Yeah, so I just kind of just did guess and check, and I just did 2 pigs and then 3 goats, so just 630 minus 600, and then I just kept getting 30 every time I went higher, so I got 30.
Okay, good. Any other ideas to kind of be sure that there's nothing smaller than this?
I think you can make an algebraic equation.
Okay, what would that look like?
So I could just use like x and y for pigs. I can use x for pigs and then y for goats. So I could do 300x plus 210y.
Okay.
Then couldn't you like factor out 30?
Good. Yeah.
Then be 10x plus 7y.
Okay.
I don't know, but I think that the outside term is the highest possible value could be, or lowest possible value it could be.
Good. Yeah.
For that.
That is correct. The reason for this is, so think about this. So whatever debt I have, right, has to always be in the form of, actually we can think about it as 300x minus 210y is an easier way of thinking about it, or this could be positive or negative, right? In this case, the x and y is like I give you x pigs and I receive x, y goats. It could be one is negative for which I receive and the other is positive for which I give. So I can express any debt in terms of like maybe 300 times 3 minus 210 times 4, right? So which is x is 3 and y is minus 4. Now, if we factor out the 30, it's like 10x plus 7y is the inside. So the smallest I can make this, if x and y are integers, of course I can have a full pig or a full goat. So these have to be integers. This thing will be an integer. If this is an integer, the smallest value I can make this is 1, right? If I make it 0, that's just an equal trade, right? So a debt, to make a positive debt, has to have this term be at least 1. And I could do this, right? I can find a value here, which would be, let's say, 5 and minus 7 is one example. And y is minus 7. So this is equivalent to trading 5 pigs, which are worth $1,500. So 5 pigs is equal to $1,500, and 7 goats, which are worth $1,470. So if I exchange these two, I'd settle the debt, $30. And that's an example of this minimum, but clearly I can't go anything below 30 because this has to be an integer, right? And if I have an integer here, the smallest I could do is 30 times 1, which is 30. Does this make sense?
Yes.
Okay. So in other words, if you look at these two numbers, it's always going to be the least common, the greatest common divisor of these two numbers is going to be the minimum debt that I could theoretically settle, right? So if I just look at 300 and 210, I should be able to tell you the greatest common divisor of these is 30. So this is 30 times 10, this is 30 times 7. So there will be some combination of pigs and goats that will get me down to this greatest common divisor, which is basically taking this factor that I took out, and I can make the rest of this 1. So that's the smallest possible debt I can settle. I could always look at it in terms of these two values and find the GCD. Any questions on this? Okay.
No.
That's it for today's class. We'll see you all next week.
Thank you.
Thank
This is what I
you.
was saying. Number of
Thank you.